Hi friends, this video is from our third chapter, that is ratio and its application, and here we are discussing the motion of a boat in a stream and how its speed changes along with the streams. And let's start. That is two different types of motion of a boat. That is the boat is moving along with the stream and it is moving against the stream. That is we are discussing. So there is two equations related to that, and it is very important in solving problems. That is, first is the relative motion of a boat when it is moving in the same direction as the stream. That is the first point we have to discuss. That is, when the boat is moving in the same direction as the stream or water current, the boat is said to be moving with the stream or downstream. It is known as moving with the stream. That is, they are in the same direction. If the boat is moving in the same direction as the stream, then it is known as downstream motion. Please note, that is in the same direction means downstream. When the boat is moving in the opposite direction to that of stream, that is, if the stream is moving in the forward direction and the boat is in the backward direction, then it is said to be against the stream. That is in the opposite direction. Please note that point. If the boat is moving against or opposite to the direction of the stream, it is known as it is against the stream or upstream. These are the two important terms we have to remind. That is the upstream motion and downstream motion of a boat. Here we are discussing. If a boat is moving with a certain speed in water that is not moving, then the speed of the boat is called speed of the boat in still water. That is, what is its meaning? If a boat is moving in a water with zero speed, that is, the water is still, there is no flow of water in that stream, that is, water is considered as a still condition, and the boat is moving with a particular speed, then the speed of the boat is known as, it is the speed of the boat in still water. It is known as the speed of the boat in still water. When it is in the upstream, that is upstream boat, it is against the stream is upstream. Against is upstream. Then when the boat is in the upstream, the speed of the water opposes the speed of boat. That is, we have to remind. That is important point. If it is against the upstream, means it is moving against the stream. That means the speed, if the water is not still, that is, it is flowing with a certain speed, then that speed of water opposes the boat's speed. That is, if it is in upstream, if it is when the boat is upstream, the water opposes the speed of the boat. If it is downstream, means it is flowing in the same direction as that of the stream's motion. That here it is aids the speed of the boat. That is, it is in downstream means both are in the same direction. Downstream means what? Water and the boat are moving in the same direction. That means the speed of the water aids the speed of the boat. Next, so we can write two equations like this. Then the speed of the boat in upstream means what? It is moving against. That is the speed of the boat in still water minus speed of the stream. That means a boat is moving in still water means it has its own speed. No effect of stream is happening. That is, in still water means only the speed of the boat is considering. The stream speed does not affect the boat speed. That is the meaning of still water. Then if it is moving in a against of the flow of water means what? The speed of the boat is opposes by the speed of the stream. That is its meaning. So we can write the speed of the boat in upstream is equal to speed in still water minus speed of the stream. I can tell or explain that in Malayalam also. That is, boat upstreamൽ മൂവ് ചെയ്യുകയാണെങ്കിൽ സ്റ്റിൽ വാട്ടറിൽ ബോട്ടിൻ്റെ സ്പീഡ് എന്ന് പറഞ്ഞാൽ ബോട്ടിൻ്റെ ഇറ്റ്സ് ഓൺ സ്പീഡാണ്. ആ സ്പീഡിനെ ഇറ്റ് വിൽ നോട്ട് എഫക്ട് ബൈ ദ സ്പീഡ് ഓഫ് ദ സ്ട്രീം. സ്ട്രീമിൻ്റെ സ്പീഡ് ബോട്ടിൻ്റെ സ്പീഡിനെ എഫക്റ്റ് ചെയ്യില്ല. ദാറ്റ് ഈസ് ദ മീനിങ് ഓഫ് സ്റ്റിൽ വാട്ടർ. ആ സ്പീഡിൽ നിന്ന് എഗെയിൻസ്റ്റ് ആയ വാട്ടർ സ്പീഡ് മൈനസ് ചെയ്യുമ്പോൾ നമുക്ക് സ്പീഡ് ഇൻ അപ്സ്ട്രീം കിട്ടും. ദാറ്റ് ഈസ് ദ സ്പീഡ് റെഡ്യൂസ് ചെയ്യും. ദാറ്റ് ഈസ് ഇൻ അപ്സ്ട്രീം ദ സ്പീഡ് ഓഫ് ദ ബോട്ട് ഈസ് റെഡ്യൂസ്ഡ് ബൈ ദ സ്പീഡ് ഓഫ് ദ സ്ട്രീം. That is its meaning. If it is in downstream, the speed of water aids the motion of the boat. So it can be written as the speed of the boat in downstream is equal to speed of the boat in still water plus speed of the stream. So here the speeds are related or with respect to the speed with respect to bank, that is the river bank. If u is the speed, now we can derive two equations. If u is the speed of the boat in downstream, downstream means the water speed or the stream speed aids the speed of the boat. If v is the speed in upstream means the speed of the boat is repelled by the stream's flow. Then the speed of the boat in still water is equal to u plus v by 2, and speed of the water current, what is the speed of the stream, is equal to u minus v by 2. How we get these formulas? We can simply find out this by how we get this. We can write, I can explain here. That is, if u is what it is given as it is the downstream speed. U is the downstream speed is u, and downstream means what? The boat speed is aided by the water speed. So we can write like this: boat speed in still water, that is ബോട്ടിൻ്റെ സ്പീഡിനെ സ്ട്രീമിൻ്റെ സ്പീഡ് എയ്ഡ് ചെയ്യും. ദാറ്റ് ഈസ് ഇറ്റ് ഈസ് ആഡഡ് വിത്ത് ദ സ്പീഡ് ഓഫ് still water. അപ്പോൾ downstream flowing current, the speed of the water current I can write like this: speed of the speed of the water current. So downstream means the speed of the boat is aided, boat speed in still water is aided by the speed of the water current, that is u. Then v is the speed of the boat in upstream. So the boat speed in still water is opposed by the speed of the water current, so its speed is reduced in upstream. So it is the speed of water current, it is equal to boat speed in still water minus speed of the water current. It is already written above. These two equations are written above. So from this we can found this is the two equations 1 and 2. Then add 1 plus 2. Then we get u plus v equal to what? BSW plus BSW. So boat speed in still water is equal to what? U plus v by, this is nothing but 2 BSW. So it is equal to, taking this 2 to this side, boat speed in still water is equal to capital letter is used. It is more better to use capital letter. So it is equal to boat speed in still water is equal to u plus v by 2. And subtract equation 2 from 1 minus 2. Equation 1 minus 2 is what? U minus V. U minus V equal to what? BSW minus BSW is cancelled out. Still water speed, speed of still water current plus speed of water current. Minus of minus, here we are getting U minus V equal to minus of minus. Equation 1 minus 2 means BSW minus BSW is cancelled out. SWC minus SWC means 2 SWC. So SWC, that is the speed of water current, is equal to U minus V by, taking this 2 to this side, it is equal to U minus V by 2. These are the two equations I already written. അപ്പോൾ നമ്മൾ ഈ ഇക്വേഷൻസ് ആണ് ബൈ ഹാർട്ട് ചെയ്യേണ്ടത് നമുക്ക് പ്രോബ്ലം സോൾവ് ചെയ്യുമ്പോൾ. These are the two equations we have to by heart for problems related to this boat and stream questions. So let's go through two examples. Here we are discussing two examples, that is that is our question is the speed of the boat in still water is equal to 20 km per hour and the speed of the stream is 10 km per hour. Find the total time taken to travel the distance 40 km upstream. Upstream means the speed of the boat is against that of, it is subtracted, it is opposes by the stream speed, that is the upstream. Then 60 km downstream. That these are the two questions. So we can write. So let's start our solving. That is the speed boat in downstream. Sorry, upstream is the first question. Upstream. Speed of the boat in upstream is equal to 40 km per hour. Sorry. Speed of the boat in upstream is equal to what? It is equal to speed of the boat in still water minus speed of the stream. That is, in upstream movement the boat speed is repelled by the speed of the stream. So it is equal to 20 km per hour minus 10 km per hour. Its speed is decreasing and it is equal to 10 km per hour. Next is speed of the boat in downstream. Boat in downstream. Downstream means it is moving in the same direction as that of the stream. That is the stream speed aids the motion of the boat. So we can add the two speeds. That is, the total speed is equal to 20 km in downstream. The total speed is equal to speed of the boat in still water plus speed of the water current, that is equal to 10 km per hour. So it is equal to, totally it is equal to 30 km per hour. And here it is given in upstream, in downstream the distance is, downstream distance is equal to downstream distance it is traveling in downstream it is equal to 60 km, and upstream distance is given as, upstream distance is, it is equal to what, it is equal to 40 km. So in different distance it is covering in downstream and upstream, so the time taken are also different. So the time taken for, time for downstream is equal to what, it is equal to 60 km by the downstream speed is 30, and it is equal to 2 hours. The time taken for upstream motion is what, it is equal to, upstream distance traveled is 40 km, and the speed is equal to, it is equal to 10 km per hour is the upstream speed is given. Upstream speed already we are calculated, it is equal to 10, so it is equal to 4 hours. So the total time taken, find the total time taken is, we have to calculate, that is the total time taken is equal to these two times, upstream motion plus downstream motion, that is 4 plus 2 equal to 6 hours. That is the answer. Next is our second question, that is a boat travels a distance of 60 km downstream in 6 hours and 80 km upstream in 10 hours. Find the speed of the boat and speed of the current. Here we can assume two variables, that is, let the speed of the boat in still water, let speed of boat in still water is equal to x km per hour. Then speed of the water current, is equal to y km per hour. These are the two speeds we are assuming. Next is given in the downstream speed, it is given as, downstream is what, the speed of the water current aids the speed of the boat. So the speed in downstream is equal to speed of boat in downstream. Speed of boat in downstream it is aiding. So downstream the boat speed in still water is aided by the speed of water current. So it is equal to x plus y km per hour. That is the speed of boat in still water downstream. Next is speed of boat in upstream. It is speed of boat in upstream, it is opposed by the water current. So it is equal to x minus y km per hour. That is its resulting speed is decreased. Here it is given as x plus y, that is the downstream speed x plus y is already given as what it is equal to? It is equal to downstream, it is equal to 60 by 6. Speed in downstream means the traveled distance in downstream, that is 60 kilometer, and the time taken for traveling is 6 hours. So it is equal to 10 kilometer per hour. Next is this can be written as the equation 1. Next is the upstream speed, that is the x minus y is equal to, in upstream it is traveled, in upstream, downstream in 6 hour and 80 kilometer in 10 hour. So it is equal to 80 kilometer by 10 hour. So it is equal to 8 kilometer per hour. This is our second equation. From this we can adding these two equations we get 2x. Equation 1 plus 2 equal to x plus x equal to 2x y minus y equal to 0. So it is equal to 10 plus 8 equal to 18 kilometer per hour. Therefore x equal to 18 by 2 equal to 9 kilometer per hour. X is equal to nothing but it is equal to what? It is the speed of boat in still water we are considered as x. So therefore the speed of the boat in still water, this is one of our question, that is still water speed is equal to 9 kilometer per hour. This is one of our answer. Next, subtract the equation 1. Next is 1 minus 2. There is no need of subtraction. So here it is given as x plus y is equal to 10 itself. X plus y is equal to 10 kilometer per hour is given. So here substituting x with 9 kilometer per hour plus y equal to 10 kilometer per hour. Therefore y is equal to 10 minus 9 equal to 1 kilometer per hour. That is y is the speed of still it is the water current, that is the speed of water current. Therefore water current is equal to 1 kilometer per hour. These are the two examples related to this topic here we are discussing. So let's go through the whole topic. Put your valuable comments in the comment box and share with your friends and subscribe please. Thank you.